This video is about straight line graphs. Y equals mx plus c is the general equation for a straight line. So we come across straight line graphs a lot. They are used with modelling, and the linear sequences we're looking at, the reason it's linear is because they form a straight line. So straight line graphs are super important, and we need to understand how that crazy equation there, the y equals mx plus c, how that relates to the graph and vice versa. Y and x are the variables of this straight line, and they will always be in your equation. So if your equation doesn't have the y and the x in it, or two letters relating to the axes, then it's wrong. The y and the x are the same as the axes or the coordinates, okay? M and c are the parameters, and they will be numbers in your final answer, and they are numbers that are unique to each graph. Let's look at what they mean later on. First of all, let's double check we know what we're doing with gradient. So, what is the gradient of this line? So we've looked at gradient before. We say, well, this has a positive gradient because as x is increasing, y is increasing. It's a positive gradient. As we move from left to right, we're going up the hill. And if we go along 1 in the x direction, we need to move up more than 1 in the y direction. We call this a steep gradient. So we know that this is a positive gradient and that the gradient is bigger than 1. So here we know that this gradient is 2. Option C. Now this is a negative gradient because as we move from left to right, we're going downhill, or you can think of it as x is increasing, y is decreasing. And to find a value for the gradient, we look along 1 in the x direction, and we're going to go down less than 1 in the y direction, which means that this is a shallow gradient. So we're looking for a negative, and we're looking for something that is between -1 and 0. So here we're expecting the -1/3. Try things for yourself. We did this activity, and you were practicing using your vocabulary of positive, negative, steep and shallow. Each straight line is defined by 2 pieces of information. If we know 2 pieces of information about a line, we can find its equation. Ideally, the simplest 2 pieces of information would be the gradient and the y-intercept. So that's the slope and where the line crosses the y-axis, the vertical axis. The vertical axis, the one that goes up and down. So where the graph crosses the y-axis and the slope of the graph. If we have those pieces of information, we can really easily write down the equation. If we don't have those 2 pieces of information, if we have 2 points that are on the line, then we can calculate the gradient from those 2 points, and we can use those points to find the y-intercept as well. And the reason why the y-intercept and the gradient are the simplest piece of information we can be given is because in this general form, the y equals mx plus c, remember we're going to be finding numbers for m and for c, and that defines each individual graph. the y and the x stay. The m is actually the number, the gradient. So all those questions we were doing before, we were finding the gradient equals minus a third or 3 or anything like that, we just put that number here in front of the x. It becomes the coefficient of x. So m is the gradient. And c is the y-intercept. So where the graph crosses the y-axis. So if it crosses the y-axis at 2, we just have plus 2. If it crosses the y-axis at minus 4, we just have minus 4. If it crosses the y-axis at the origin at 0, it's just plus 0. We don't have anything there. It can be a decimal, it can be a fraction. Same here for the gradient. Decimals, fractions, all of that go in there. Okay? But m and c are just numbers, and they're the numbers that define that specific graph. Let's have a look at an example. So, the equation from a graph. When you're doing these questions, you always write down the general form. So you say, well, it's y equals mx plus c that I'm using. I'm very clever. I understand that that's what I'm doing. Looking at the graph straight away, I can see, well, c is equal to 0. So I'm actually just going to have a y equals mx. As I go along 1, I'm going up 2. So my gradient is 2. So my final answer is y equals 2x. The gradient, the change in y divided by the change in x. So I've gone 2 in the y direction and 1 in the x direction. Your turn. You try this one. So I've written this in 2 different ways so that you're practicing your algebra. This one, clearly a negative gradient and it's shallow. If I check how I find the gradient, I pick any 2 points. So if I pick this one here and this one, the change in y, so I'm going minus 1 in the y direction and 1, 2, 3 in the x direction, so I get minus 1 over 3. Now let's look at another example. So again, we always write down y equals mx plus c to show how clever we are, that we understand that this is a straight line and that this is the general form. Then we look and see. Well, c is equal to 3, because that's where it crosses the y-axis. And m is the change in y divided by the change in x. So here's 2 wonderful points. I'm going down 2 and along 1, so that's 2. So my final answer will be y equals 2x plus 3. Your turn, you try this one. So checking the gradient, 2 points that we can read exactly. Here's 2. We're going along 3, 1, 2, 3, and down 1. So it's minus 1 over 3. So y equals minus a third x minus 2. You'll notice that these graphs have the same slope. They look like the same graphs as in our previous example. They've just been moved, they've been translated up or down. And that you can see, the only thing that's changed is the y-intercept. Try these questions. And here's some questions for you to try in your exercise books. Here are the answers, so check your work and make sure you ask for help if you've got anything wrong and you don't know why. Now let's look at how we would draw the graph when we're given the equation. Before we had the graph and we had to write the equation. Now we have the equation and we have to draw the graph. So to do that, we look and we see, well, it's going to cross at -1. So this is going to be a point here on our graph. It's going to cross at -1. And it's going to have a gradient of 2. So that means when we go along 1, we're going to go up 2. So our straight line is going to go through these 2 points. We can now take a ruler and draw that in. You can also substitute in any values that you like. So you could say, right, well, I want to know what y is going to be when x equals 2. So 2 times 2 would equal 4. So when x equals 2, you'd get y would equal 2 times 2. Take away 1. So 4 take away 1 is 3. So you would also have this, you could have this point. You can use the gradient or you can substitute in points. But always mark in the y-intercept, especially if it's a whole number. If it's not a whole number, then you might want to substitute in values. So we can then draw our graph. You should try this one. So we can see it crosses at 4 and has a gradient of -3, 1 along, 3 down. Let's look at another example. Here we're going to be crossing at 2, crossing the y-axis at 2. We're going to have a gradient of -1/2. So for every 1 we go along, we're going to go down 1/2. So I'd have to go along 2 to go down 1. So then that would give me 2 points that I can join with a ruler and draw a straight line. And my straight line would go across the whole graph. I don't just draw a tiny little section of it here, a segment. I draw the whole thing right the way across the grid, like I have here. And then you can try this one. So it crosses at -3 and has a gradient of 1/3. So for every 1 I go along, go up 1/3, so I have to go along 3 to go up 1. This hasn't come out exactly. Try these questions for yourself in your notebooks, drawing the graphs with a ruler and a pencil and some axes. Here are the answers, so you can check your work.